Section 8.3, Solving Linear Equations, ax plus b equals cx plus d. In this video, we're going to learn how to solve equations where we have variables on both sides, so they look like ax plus b equals cx plus d. And then we're also going to understand what we mean by the terms conditional equation, identities, and contradictions. So let's look at our general procedure for how to solve equations where we have variables on both sides. So we're of the form ax plus b equals cx plus d. The first thing we want to do is remove any grouping symbols that we might have with like parentheses, and then we want to combine all of our like terms on each side. Then we're going to use our addition principle of equality to get our constants and our variables on opposite sides of the equation. So one side will contain the constants and one side will contain the variables. Then we'll use the multiplication and or division property of equality to get our variables so that it has a coefficient of 1. And then as usual, the last thing we need to do is we want to check our answer by substituting back into our original equation. So let's start with a simple example. Say we have 5x plus 3 equals 2x minus 18. Well, we have no grouping symbols and we have no like terms on each side. So what we're going to do is we're going to get our variables to one side and our constants to another. So I'm going to start by getting my constants. I like to try to get my variables over to the left and my constants to the right. Sometimes it's easier to do that in a different order, but I'm going to start by subtracting 3 from both sides. When I do, I get 5x, those cancel to give me 0, equals 2x minus 21. But now I've got a 2x and a 5x that are on opposite sides of the equals. So what I can do is subtract a 2x from both sides. So 5x minus 2x would be 3x. Those will cancel, and I get equals negative 21, and then I divide by 3. And x equals negative 7. Now we'll take a moment and check this one just to show that we did get the right answer. So we'll take our original equation, 5x plus 3 equals 2x minus 18, and we'll substitute in the x is negative 7. So 5 times negative 7 would be negative 35 plus 3, and 2 times negative 7 would be negative 14 minus 18. But negative 35 plus 3 is negative 32, and negative 18 minus, or negative 14 minus 18 would also be negative 32. So that is correct, and our answer is that x is negative 7. Notice in this problem that we have some like terms on either side of the equation, so we're going to do some combining first. One of the things that is sometimes helpful to see the two separate sides of the equation is you might want to draw a line where your equals would be to kind of separate the two sides. So looking at the left-hand side of the equation, you've got 4x minus an x, which is a 1x, so that's a 3x, plus 1 equals, then on the other side you have 2x, and then negative 13 and positive 5 would be negative 8 when I combine those. So now I've simplified to here. Now we'll go ahead and get our variables to one side, our constants to the other. So I'm going to subtract a 1 from both sides and get 3x equals 2x minus 9. Then I'm going to subtract my 2x. But 3x minus 2x is just x, and then the negative 2x, positive 2x are going to cancel and leave me just negative 9. So my answer is that x equals negative 9. Looking at this equation, again, we see that we don't have any like terms on either side of the equation, so I'm just going to draw a real light yellow line so we can kind of see the two sides of the equation. We don't have like terms on either side, so let's get our variables together and our constants together. So this time I'm going to move my variables first so you can see it doesn't matter which way you do it. 6y minus 7y would be negative 1y, or just negative y, plus 2.5 equals, and then the other side would be negative 3.6. Notice that there's a negative in front of your 3.6. Now we're going to subtract a 2.5. So I get negative 1y equals, well, negative 3.6 and negative 2.5 would be negative 6.1. Then we divide by negative 1, and y would be positive 6.1. Again, we have a similar equation, but this time we have fractions to deal with. I'm actually going to show you two different ways to solve this. So let's look at the first way, which is what we've already been doing. Where we will combine our variables to one side and our constants to the other. So I'm going to subtract a 2/5 x from both sides. And when I do that, 1/3 minus 2/5 will give me negative 1/15 x plus a 6th equals negative 7/10. Then we'll subtract 1/6. And that's going to give me negative 1/15 x equals, and if we do negative 7/10 plus negative 1/6, we get negative 13/15. Then we'll multiply by the reciprocal, which would be negative 15/1. Well, this gives me just 1x on my left-hand side, and then I can simplify that 15 and negative 15 have a common factor of 15, and I get 1 and negative 1, and then negative 13 times negative 1 is positive 13/1, or x is 13. Now, a different way that I can solve that equation is to eliminate the fractions. So, if we have 1/3 x plus 1/6 equals 2/5 x minus 7/10, what I can do is look at all of my all of my denominators, 3, 6, 5, and 10. And what I want to do is find the least common multiple. So what would be the smallest thing that would be divisible by 3, 6, 5, and 10? Well, as it turns out, that number is 30. So what I can do then is multiply each number in that problem by 30. And if I do 30 times 1/3 x, I get 10x, plus 1/6 times 30 would be 5. 2/5 times 30 would be 12x, and negative 7/10 times 30 would be negative 21. Now we can combine like terms. We're going to subtract a 5 from both sides and get 10x equals 12x minus 26. Subtract the 12x and we'll get negative 2x equals negative 26, and divide by negative 2, and x is 13, which is what we got when we worked the problem out the other way. But notice that in this case we eliminated the fractions, which is nice if you don't have a calculator handy or you're just not good at working with fractions. Now let's look at a problem where we've got some grouping symbols. So what we're going to do here is we're going to use the distributive property to multiply negative 2 times both 5x and 13. So if I do negative 2 times 5x, I get negative 10x, and negative 2 times positive 13 would be negative 26. Then we'll just bring down my negative 2. Then again, I'm going to use distributive property here and multiply by negative 6. Negative 18x and negative 6 times negative 2 would be plus 12, and bring down the 41. Now let's look to see if we have some like terms we can combine. Well, on my left, I do have a negative 26 and a negative 2, so that's going to give me negative 28. And on my right-hand side, I've got a positive 12 and a negative 41. So that's going to give me negative 29. And now we can start moving things around till we get our variables on one side, our constants on the other. So I'm going to add 28 to both sides. Negative 10x equals negative 18x minus 1. Then add 18x and get 8x equals negative 1 and divide by 8. And I find that x is negative 1/8, which you could leave as a fraction, or you could use your calculator and get that as a decimal value. Another example with parentheses, let's start with distributive property. 4x plus 12 equals 6x minus 2 plus 6. Combining like terms, on the right-hand side, I can put negative 2 and 6 together, which would give me plus 4. And now we'll subtract 4x. Remember, it doesn't matter whether I subtract the variables or subtract the constants. Then I'm going to subtract 4 and get 8 equals 2x and divide by 2, and x is 4. Now we're going to look at a few problems that involve what we call conditional equations, identities, and contradictions. A conditional equation is an equation that has only one solution. Up to this point, every equation we've looked at has been a conditional equation. An identity is an equation that is true for all values of x, so it has an infinite number of solutions. Any value that you pick for x will make that equation true. And then a contradiction is an equation that has no solutions. In other words, there's no value that would make that be a true equation. So let's look at this equation and determine, is it conditional, is it an identity, or a contradiction? So we'll start by doing distributive property and get 3x plus 15 plus 1 equals negative 11. We'll combine these and get 16. Now I'm going to subtract the 16 and get 3x equals negative 11 minus 16 would be negative 27, and divide by 3. X equals negative 9. Since we have one solution and it is negative 9, then we say that this is a conditional equation. Now let's look at this equation. We have 3 times x minus 25 plus 3x equals 6x, 6 times x plus 10. So distributive property, 3x minus 75 plus 3x equals 6x plus 60. Combining like terms on the left-hand side gives me 6x minus 75 equals 6x plus 60. So I'm going to subtract 6x from both sides. Let's get our variables together. But those cancel and give me negative 75. Those cancel and just give me 60. Well, negative 75 never equals 60. So what that tells me is there is no solution to this. And there's several ways I can write that. One is to write it with an empty set of brackets or a 0 with a slash through it, which is called the empty set. And what that means is that this is a contradiction because nothing would ever make this true. For our last example, let's start with distributive property. Negative 2x plus 14 plus x equals 14 minus x. Let's combine like terms. Negative 2x and positive x would be negative x plus 14 equals 14 minus x. Let's add x. And this time I get 14 equals 14, which is true. So that means that all real numbers are a solution. So any value you pick for x will make this true. And when that happens, we call those equations identities. So this would be an example of an identity.